we started off, we didn't think we were going to have to do the full development. We could come up with the idea and maybe someone else would demonstrate it, maybe someone else will build the first plant. But in doing this, you realize that, oh no, we have to take this all the way on the journey, and started getting comfortable with how best to do that in a capital efficient way and really rely on existing industrial expertise. I think this is a really key thing in the climate tech space is there are companies who've been working on minerals, on mining processing, on making paper, and they know so much more than we do.
Welcome back to the CleanTechies podcast, where we interview the top climate tech founders and investors to share their stories, advice, and lessons when it comes to building and investing in climate. Our guest today is Adam Goff, the SVP at 8 Rivers, a climate deep tech technology developer. That's kind of how I would classify them. And what that means is they develop new technologies which are then spun out and commercialized under separate platforms. So you can kind of think of it like a research lab with kind of a certain goal in mind, and then spinning out those companies once they kind of formalize the technology. Two other companies that are similar to this model are Cemvita and Solugen, which many people have heard of as well. Adam's story is pretty interesting. So he worked originally in policy and had pretty good familiarity with the 8 Rivers team. And once the 45Q tax credit was passed, he ended up hitting up the team and joined them when they were about 20 people. And today they are at around 70 and they now have 3 technologies commercialized. And in today's conversation, we spend a lot of time talking about the role of policy in climate, along with how that plays into the strategic aspects. Kind of that's his main role, is advising around those pieces and going to market. We then talk about how the technology development model works generally, along with the actual commercialization process of their first technologies and how they make money, broadly speaking. And then we wrapped up with kind of the main challenges and opportunities present in building hard tech. So a very interesting and wide-ranging conversation with a very knowledgeable guest. So enjoy the episode. All right, welcome to the show, Adam. How's it going?
Hey, Silas, I'm doing well. How are you?
I'm good. I'm fine as frog hair. It's a new year. Obviously, this will come out later, but we're recording this on the 5th of January. So super excited to chat with you. And I guess let's just get right into things. Give us a quick kind of background on who you are, what you're doing, and we'll go from there. Hey there. Are you building a climate tech business and looking for very specialized talent? Consider reaching out to our sponsors, NextWave Partners. NextWave are experts in talent acquisition, recruitment, and retention across the climate tech, renewables, and ESG spaces globally. So if your team is growing or you're looking to make a career change yourself, feel free to reach out to NextWave at next-wavepartners.com or reach out to one of their consultants directly via their LinkedIn page.
So I'm the Senior Vice President of Strategy at 8 Rivers, and I work on developing carbon capture technologies and projects. So I've been working on this for almost a decade now, with the last 5 years at 8 Rivers. Started working in the policy space, so was in DC working on carbon capture policy with the Department of Energy, with Congress, at a nonprofit called ClearPath. And through that, got to know 8 Rivers and some of their portfolio companies as well. Got really excited about the technology. And around 2018, Congress passed this big tax credit called 45Q that incentivized. And I saw that tax credit come out. We had worked on it at ClearPath, and I called up the folks at 8 Rivers and said, hey, I want to come and help build the business now. We have this policy in place. Now's the time to build projects and actually deploy innovative technologies. So joined the firm back in 2018 when we were less than 20 people, and now 5 years later we're sitting at nearly 70 and deploying a couple technologies, having raised $100 million plus into what we're doing here. So it's an exciting time.
Nice. No, I like this. We'll get into a bit more about the structure and everything, because I think it's quite an interesting model, if I understand it correctly. But I am kind of curious, you work in a strategy role, and you said your background was in policy. That's where you started. Could you talk broadly about, because we haven't had many people who have this perspective, talk about the role of policy in climate tech building companies, right? Like as a strategy role, because usually, when I've worked in renewables, strategy isn't usually like the core principle isn't usually a policy. So I'm just kind of curious to understand your perspective on that and why it's important.
Sure. So a lot of what I think about is where's the best place in the world to deploy our technologies, right? Who are the best partners for us to work with? And for carbon capture in particular, but really any clean tech, it is driven and related to policy, right? Because we are trying to accelerate the energy transition, and maybe there are some things that are getting accelerated because the technology is that much better. most of the time you're interacting with government policies for accelerating renewable energy or for storing CO2. So carbon capture in particular, we need rules around storing CO2 and how you can inject CO2 and monitor it and do that in a safe way. We need incentives of some kind, whether it's a penalty on emitting CO2 or a subsidy for capturing it, in order to make carbon capture work. It's always cheaper to emit CO2 than it is to capture and store it. Right? That's how we got into this whole mess. And so very much the places we build, the different opportunities for us to build clean hydrogen or build clean power is dependent on what different governments at a state level or at a national level, what goals they're setting, what policy regimes they're putting in place to incentivize that transition. And I think that's broadly true across climate tech. If you look at deploying better air conditioners, or you look at solar panels, you look at electric vehicles, it has to be a better product, but also it has to fit into usually national energy and climate policy. I would be just thinking about policy and government relations and communications all day. It is a minority of what I do. Right? So I think that's where my background comes in. But when we really are looking at deploying technologies and projects, it looks much more like energy project development, right? Where you're working with seeking out land parcels, you're working with major OEM partners, you're talking to financiers. Government's a part of that, and I think it's a big part of where it makes sense to do something when. But it's a minority of the day-to-day work when you're actually trying to build a plant in the real world.
Yeah. So I guess could you talk a little bit more about that? Because it seems slightly contrary to some of the people we've had on the podcast that talk about the best climate technologies. Again, obviously there's certain circumstances where you certainly need kind of the regulatory environment to be right. But a lot of people we've had on, especially the investors, are really focused on finding companies that are doing things where, regardless of the regulatory situation, their product is better and cheaper and cleaner, of course, that the companies will adopt it anyway. So can you talk more about like maybe exceptions to the rule that you think?
Sure. I mean, that's the best. If I was an investor, that's the best kind of product, is one that is better even without regard to its CO2 benefits. Right? I think electric cars are a product that are there, right, where people are going to buy Teslas or Rivians or Volts because it's a nice car, right? And not because it doesn't have a tailpipe. I think one is often to get to that phase, they go through a policy-dependent phase.
Yeah.
Right? It's a rare thing that can get to, when you're at massive scale, solar panels are maybe just a better product, right? And so they compete on their own. To get there, right, there's 50 years of government R&D, of German performance standards, of U.S. Renewable portfolios. There's this whole history that gets it there. And that's one piece, is that often there's a journey. And I do think some of our technologies do get to that point where, we have a power plant we're working on that is run on CO2, and it can just be a better technology eventually. But right now, it's, we're largely relying some on tax credits. I think it also depends on which sectors you're decarbonizing. We typically are working on large industrial plants, things like power plants, fertilizer plants, refineries, and then steel plants. It is rare that you have solutions for those systems that work without any kind of price on CO2. So I think it's also, some of these are the hard to abate sectors, right? It's okay, these are the harder ones, right? Where with light bulbs, which is something we once thought might be hard, now just LED light bulbs are just better, right?
Yeah.
So I think it's also just I think something in climate tech is the sectors are not all that similar. Even inside of the industrial sector, the process of making paper and the process of making ammonia, not very similar. Right? All these different slices of the problem are hugely different technically than each other.
Hey guys, sorry for the interruption. I just need a few seconds because Soma and I have two quick favors to ask. Putting out the show each week takes about 15 to 20 hours between us, so it's a lot of effort, and it would mean the world to us if you would leave a review and mention your favorite episode. Secondly, if you're not already, go over and subscribe to the podcast on Substack. The content is free, but if you like hanging out with us each week, maybe we're even the kind of guys you'd like to buy a coffee for on occasion, consider becoming a paid subscriber. For the cost of one lavender latte a month, you can help us immensely. Thank you for tuning in consistently and helping us to share our guests' stories. Now back to the show. Yeah. Do you, I know we're going pretty into things, but before we get into the background of the company more, but do you foresee any particular way or method to, if it is required to, not required, but in most cases, very, very useful, let's at least say that much, to have the regulatory bodies say like, okay, here's like the baseline to get things jump started. If that's the case, and it usually, regulation is in many cases reactionary, but we're trying to be proactive and get things going. How can we shorten that timeline from a long period to a short period in order to get more technologies to that scale size?
I think we're at least in the US, we're in a pretty lucky position of it's mostly in place, right? So if you're looking at building a climate tech company today, I think you should assume that there are not any new laws that are passed or new regulations that are going to enable your technology. And there's a host of existing programs, cap and trade style policies, tax credits that already exist. The Inflation Reduction Act put many new ones in place, but I think, agree with you that to scale, the policies have to be in place today, and some in the U.S. And in the U.S., we actually have a lot. So if you're developing, renewable natural gas type technologies, you're probably going to rely on the Low Carbon Fuel Standard, which is a California program that has an incentive program where polluters have to pay for some low carbon feedstocks. Solar and wind have been getting their tax credits since the 90s. So we have this long regime. For carbon capture, there's a specific tax credit for nuclear, for geothermal, for electric cars. Like there is a system. In the US, it's mainly tax credit based. I think the other benefit here, and one of the challenges relying on government policy, is you don't know if it's going to be there next year. Right.
Yeah.
You both have, is it going to exist at all? And once it exists, how long can you rely on it? But I think a nice thing in the US is we have these policies that have been here for a long time. People have built $1 billion of businesses on top of the investment tax credit for, say, for solar panels. And that gives investors comfort, and it gives companies comfort that we know all the rules around how to operate this. We know what parts of the program are stable and what parts are political footballs. And that's just important knowledge that you don't get immediately. So like having older policies is often a benefit. It takes the market a couple of years and the bureaucracy a couple of years for things to shake out about how any new program might function.
Mm-hmm. Yeah. Okay. Interesting. No, I appreciate that. So let's go, I guess, to talk a bit more about Eight Rivers. So can you tell me more about the history of how it got started? Because we understand how you ended up, deciding to go there when you saw the writing on the wall that it was really good timing. But how did they get started? How is it structured? Like what is the MO of Eight Rivers?
Sure. So Eight Rivers has been around since 2008. It was actually Bill and Miles had been in school together at MIT when they were college kids, and they went off and had their own careers. And towards the end of their careers, they were talking to each other and realized they both wanted an opportunity to contribute. Bill had been working on Wall Street. Miles had been working in defense and on weapons development, and they both felt that they could bring their expertises together and do something that was purely mission-based, right? Something that is a business, so can finance itself, makes money, but is targeting, sustainable infrastructure that's good for the world. So they formed Eight Rivers to invent and commercialize sustainable infrastructure, and kind of taking Bill's experience on Wall Street and Miles' experience, kind of invention and innovation, and on the technology development side. So we started off with a pretty broad focus. We looked at everything from, we looked at telecom, we looked at space launch, and really over the next couple of years narrowed in on the energy sector. Rodney Allam kind of joined the company. He's our master inventor and has invented many of the technologies we have at Eight Rivers. And through a number of years, we kind of stumbled towards this model. We didn't start at the model where we invent technologies in-house, trying to use existing components as much as possible, but in new configurations that have inherent CO2 capture, manipulating the properties of CO2 at different temperatures and pressures. We then demonstrate that technology and then build the first plant of it. And I think we started off, we didn't think we were going to have to do the full development. We thought, we could come up with the idea and maybe someone else would demonstrate it, or we could demonstrate it, maybe someone else will build the first plant. But in doing this, you realize that, oh no, we have to take this all the way on the journey, from the patent that's submitted, and started getting comfortable with how best to do that in a capital efficient way and really relying on existing industrial expertise. I think this is a really key thing in the climate tech space is there are companies who've been working on minerals, on mining processing, on making paper, on processing flue gas for 100 years. And they know so much more than you do. And you probably have this innovative idea, but you really need to work closely with the supply chain, both because you should not try and rebuild all the industrial building blocks of any technology, and because they've got tons of expertise. So we've really kind of tried to specialize in partnering with these large equipment manufacturers, these large technology companies who have those decades of experience and working on our technologies with them. So that's been true across the direct air capture technologies. That's been true on hydrogen and on the clean power side as well. And so I think we come to this model at the end of the day where I think some of the things that make us different is one, we don't just do one technology. I think many of the smaller companies in our space who aren't, like ExxonMobil or something, they do one thing, which, has a nice focus to it. But having a portfolio of multiple clean energy technologies, we found to be pretty useful. There's a lot of learnings between them, right? So there's, we're working on carbon capture, so there's similarities between them. It allows some cross-pollination of ideas between different sectors, and it kind of smooths out our risk a little bit, right? Because we're exposed to multiple different sectors, and we can share resources where we can have, a communications person or an engineer and have that expertise that can work across multiple technologies. So that's one thing that makes us different. And I think we do really go all the way from the technology invention side to we're out developing projects, signing land deals, getting off takes.
Mm. So in some ways, it's almost like a venture studio, but specifically building different technologies. And then is it pretty common that you're able to leverage off of your past experience in the technology development to build new technologies? Is it usually a good overlap?
Yeah, it's very high overlap. I think if you look at all of our technologies, so the direct air capture, the clean hydrogen, and the clean power, you're going to see oxy-combustion in pretty much all of them. So burning fuel in pure oxygen rather than air. And you're usually going to see us manipulating the properties of CO2 and using CO2 as a heat transfer fluid. And so there's a lot of similar core ideas that we're applying into different sectors.
Mm-hmm. Okay. And the thing I wanted to ask you about, because it seems as though you've gone through this process several times, is uh, just to recap the idea that you wanted to build something, you figured, hey, we'll get this technology out there, and then somebody else will go pilot it and build it. And you realize, hey, that's not the case. So we have to go build it ourselves and demonstrate that it works. And then from there, people are going to buy in and they'll try it, right? Can you speak to the process? We don't need to necessarily know the particulars of the technology. What does the process look like? Because there's a lot of companies building technologies in this space where they have a new technology. They need to demonstrate that, hey, this does work, rather than telling somebody else, go do it. I'll promise you it works. Can you speak to that process, kind of a 1, 2, 3 steps of from lab technology, how to get through to that pilot project? What are the major things that people need to be aware of before a large corporate will say, you know what, we're willing to license that from you?
Yeah. It's a hard question, so let me think for a second. I will first say, I think you often, after you build the pilot, you also maybe have to build the first commercial plant. So I think most of the corporates who might license it to you, they want to be second. And they want to be second where you have a first plant that's identical. So I think often there's this hope that, hey, we demonstrated it, someone's going to go build the first. I think they might be able to, but it's also easier to bring them along if you're planning to do it on your own. Because it shows this confidence that, hey, we believe in this is going to work. We're going to go do this at the full scale. Come join us in this journey, rather than we think it's going to work. Will you pay for it? Right? And will you do it? Because we don't want to do it. Like it's a different message there. But on the pilot side, I think it's hard, and I think it varies by technology, but a couple lessons or things I think we can draw from our experience. One of which is you want to have designed the large system before you design the pilot. But the point of the pilot is to teach you things and allow you to scale up and spend the $100+ million you need, or that someone else spends it on a full-scale plant. And to design the pilot correctly, you need to know as much as you can about what the large scale plant looks like. It's a little chicken and egg, because to design the large scale plant, you need the data from the pilot, right? So and we're going through this on a direct air capture technology right now, where we're in the process of finishing up the design of the pilot and then building it over the next year or so. And you have this feedback between, to design the pilot, you need to see the big plant. To design the big plant, it's gonna be informed by pilot data. But I think that interchange is pretty important. Otherwise, you might have a successful pilot and realize you didn't de-risk something key because you didn't, some dimension was too different, or you didn't have some piece of equipment in the pilot that you wanted to test. I think also trying to have as many vendor similarity, right? And so in the pilot, where you can, bring in vendors who could help you build a big plant. Because when you build a big plant, you're going to try and get dead on it probably. And so you're going to want to guarantee. And to get a guarantee, every single one of your vendors is going to have their own guarantee that gets built up into this master guarantee. And so you really do need to think about, is this someone who can deliver the equipment at a larger scale? Do they have a solid balance sheet that would enable them to make the kind of commitments we're going to need for a large scale plant? So I think that's key. And the third thing I would say is really looking for what equipment already exists. So where you can, there's a lot of test facilities, there's a lot of national labs, and there's a lot of equipment other people have built, and there's a lot of existing industrial facilities. Spending a lot of time scrubbing the world for the best place to build it, which is not as easy as it sounds. I think we still find, 10 years in to looking at sites like this, you're still finding really amazing places at universities or owned by corporates that have great capacities that you didn't know about. And so I think that can often save you a lot of cost and headache, because if you can find someone who has a test facility, can then run at those pressures, or has unused industrial equipment you can reuse or something like that.
Mm-hmm. That's really helpful. I think those are really concrete examples. I appreciate that. That's good. I don't think we've heard any of those, actually. I mean, the existing equipment one has been brought up in some ways, but not in that particular method with the guarantees as well. Okay, very cool. So can you walk us now through what are the key technologies that you have now at 8 Rivers? What are the things you're doing now? And can you explain also, along with what they are, how they work, just kind of really high level?
Sure. We have 3 main technologies that we're advancing. So one is called 8RH2. It's a clean hydrogen technology that takes natural gas and turns it into hydrogen while capturing all the CO2. So this is a key process that's used today mainly to make fertilizers and to make fuels, is what hydrogen is currently used for. And it's something that's going to be really useful in the future for fueling marine transport, and potentially replacing coal in certain power plants through its use as ammonia. So it's one of the key building blocks of the energy transition. What we've done is we've designed a system that has inherent CO2 capture by using CO2 as the heat transfer mechanism. So we have something called a carbon convective reformer, which is replacing what's called a steam methane reformer. So in today's technology, you use steam to basically heat up these catalysts and reform this natural gas to hydrogen. And we're actually using hot CO2 instead of steam. And so out of the back end, we get a pure stream of CO2, rather than having what you have at a current hydrogen plant is you're going to have a mixture of CO2 dilute in air and water, where you then have to capture it. So that's the core technology. It allows us to have higher efficiencies, lower air pollution, and we think have a low-cost system that has really high rates of carbon capture, so getting to about 99% carbon capture.
Hey guys, we need your help with something. In order to better understand what you like most about the show, what you dislike, and how we can help you, please take 7 minutes to fill out our listener survey if you haven't already. It only takes about 7 minutes, but it will drastically improve our ability to give you the best content that you're looking for. Thanks for your help. Now back to the show. Got it. Okay, so just to clarify then, that is all one technology, and the carbon capture is intended to capture as you create the hydrogen, correct? It's not like here's a carbon capture technology, we're just going to go deploy it to capture carbon. This is a holistic system in order to create green hydrogen, correct?
That's right. I think they technically call this blue hydrogen if we're going to be coloring things. So hydrogen from electricity, from renewables is typically green. Hydrogen from natural gas that has carbon capture is blue. But yeah, when we say carbon capture, we typically mean carbon capture on top of some other energy process where your main goal is to make electricity or make hydrogen, and we have a CO2 capture system integrated in that. I think it's a little confusing because there's also what we call carbon removal, which is pulling CO2 from the air, or
Mm-hmm.
direct air capture, it's a great segue, Silas, to our next technology, which is something called calcite, which is pulling CO2 from the air. It's different than the technology to integrate with industrial systems where, really the main product is hydrogen or the main product is power and you're making it clean. With direct air capture, all we're doing is pulling CO2 out of the air and putting it into the ground in order to remove it from the atmosphere. So we do that with calcite, which is one of our newer technologies we've been working on for 4 or 5 years now. We use calcium. So we use the same chemistry that lets mortar stick things onto your walls or sidewalks. We're using calcium hydroxide, and we make it really reactive. So it absorbs CO2 directly from the air and forms calcium carbonate. And we can then heat that up in a kiln, release and capture the CO2, and cycle the calcium again. So calcium is the main way that the Earth manages its own carbon cycle over millions of years. Calcium likes to absorb CO2. And so we're able to manipulate that calcium cycle, speed it up, and put it in what basically looks like a long block of fans. So for us to pull CO2 from the air, we need to move huge amounts of air, ungodly amounts of air, and you do that with what looks like a cooling tower. So you may have seen these, at power plants or outside of hospitals. They've got like a ceiling exhaust fan and what are called louvers, but they look kind of like window shades that pull air in and then exhaust them through the center ceiling of the building. So that's we're working on a DOE-funded DAC hub. So DOE funded a couple of hubs to advance this newer technology with a bunch of different approaches. Ours is one of those approaches. So we have a hub in Alabama where we'll be building a pilot on our own, and then with DOE we'll be designing a full-scale facility to pull CO2 out of the air.
Mm-hmm. Okay, got it. That makes a lot of sense. And then, was there any other major ones that you
Yeah.
wanted to highlight for the technologies you have currently?
So the third one is called the alum cycle. It is a CO2 cycle to make power. So it's if you imagine a current power plant is driving a turbine with steam or nitrogen, we're actually driving a turbine with CO2. So it's a CO2-driven turbine. We are a minority owner in Net Power, which uses this technology. We licensed it to Net Power, and they're a public company on natural gas. And so they own the natural gas version of that cycle, and we're developing now the version on solid fuels like biomass. So to take wood chips or organic waste or any kind of biomass-derived fuel, gasify it into a syngas, and use that syngas to fuel a power plant that has a CO2-driven turbine. Across all three of these technologies, you have oxy-combustion, and I'm not trying to avoid too much chemistry here, but we're burning typically in pure oxygen, and we're circulating CO2 into that combustion chamber with that oxygen.
Mm-hmm. Okay, cool. Yeah, that's quite interesting. So it does seem that there's the similar theme across them, right? And it maybe goes from one once you master one, you can build upon it and do other things. So the thing that's always very fascinating to me is understanding the business model. So now that you obviously raise money to go build these pilot projects and do this technology. Before we get into commercializing it specifically, on the raising side, I don't know if you can speak to this or not, but how did you, is this fundraised for in a different way than a company specifically developing one technology? Because it sounds like it has this kind of venture studio model where we're building a whole bunch of things. Is it more of, hey, we're going to do a lot of this stuff, we need to raise a lot of money to do the R&D process, and then we're going to license it? Like, is it
Yeah.
still very similar in terms of the raise?
It's a great question. I've got kind of two different threads of comments on this. One of which is we have this choice internally about whether should we raise money into a technology, right, and then raise capital into a technology, or into the company that owns multiple technologies. It really, it's different, right?
Mm-hmm.
So on the one hand, raising into a technology is simpler. You're telling one story. You have to find investors who believe in that and who add value. And so in some ways, that's simpler. The good thing about having a portfolio is that it allows them to hedge their risk, right? Of saying, okay, I'm making multiple bets, right? but it's more diligence, right? And they have to, all of these things, as you probably can tell, are complicated. There aren't a ton of people who can really vet them out and do diligence. So I think both approaches work. I think it really depends on the blend. This is what Wall Street does, is they bundle and they unbundle, right? Like sometimes it makes more sense to have things combined to, hedge risk and have synergies between them. And sometimes it makes more sense to have them separate, and you kind of often alternate between those two things over different cycles. And with the portfolio, we still have that freedom, right? So we have raised money at a portfolio level. Our major investor is a Korean company called SK Group, who own a majority of the shares in 8 Rivers. We also still have the flexibility where even as the portfolio company, you always can raise money directly into a subsidiary. Heck, we're a minority owner of something that we invented, right?
Yeah.
And so you have that choice. I think one of the interesting things about the portfolio, more than the raising, is I do think it's more innovative. I just think it's easier. I think we've experienced this, that having a lot of the same people inventing across multiple spaces, it looks a lot like the corporate labs, at least when I read about them, that drove a lot of American innovation in the 50s and 60s and 70s that we don't see as much anymore. So that was thread one. The second thread here is we've been very strategic focused. Like we really haven't raised money from financial investors or the traditional VC ecosystem. I think both, it's hard for them to diligence it. I think it's a lot harder to fit with the kind of hard tech we do, like big expensive power plants that cost hundreds of millions, if not billions of dollars. It's hard to fit into the venture model, and it's hard to fit into, like, if you're a bank, or just purely a financial investor. And so I think we end up finding the best fit with strategics who, they know this stuff, right? They've been working in minerals, they've been operating power plants, and so they can really understand the technical risks. I think that's the key thing, is you need investors who can really understand the technical risks. And they can help, right? They can look at our business and say, wow, we can make you guys a lot better, right? Because we have this engineering expertise, or we own these assets, or we supply this equipment. And they can see a strategic impact on their business beyond just our own returns. So this is something that's hard in hard tech, is that you have all these great technologies that are good for society. Often the people who invent them don't make the money, right? Not always. So A, you have to patent and license and make sure that you're going to make a return on it. But B, if you bring in investors who are going to get some of those positive spillover effects, right? That they say, oh, this is going to create a bunch of value for us that you guys maybe we're not going to capture. It's going to make some of their existing assets more valuable, but it puts them in a good position to see that value and invest in the long term in these technologies.
Yeah, it just makes it kind of reminds of the importance of alignment, right? Because if you're going to pitch a VC and they're like, well, I don't understand this, it's going to be very difficult. But if you go to somebody else, they might be willing to put up more money for a lower price because they realize the value of it in the long term if it does work, or where maybe it's a situation where they understand the potential outcome is so great that even if it doesn't work, it's still worth that large investment, which to a VC could be their whole fund, right?
Yeah.
But to depending on size, but to them, it's just like a part of their daily operations, right? They can do that. So quite interesting. Could you talk about then the commercialization? So you obviously have a portfolio that owns and creates these technologies and then turns it into new portfolio companies. And is the commercialization path the same across all of them, where it's like, hey, once we get this pilot project, we're going to go, sell licenses and help them build the technology. Can you just talk us through that? How do you make money?
Mostly. So the simplest model is that, hey, we have a first plant that works and we sell licenses to anyone, right? That anyone who wants to build the technology, they can go take a license from us. They pay you an upfront fee, maybe some ongoing fee. And so you have this early capital intensive business that then becomes this really capital light, attractive business where you're monetizing your IP, continuing to innovate and improve it. And the assets are owned by companies who specialize in owning assets, right? Oil companies, power companies, processing companies, fertilizer companies. Their whole business is managing existing assets. So I think that's probably the main way, is that license revenue is long-term the main way. The other way is developing and owning projects, right? You yourself could develop these. And I think one of the things we've realized is, as the technology inventor and developer, it puts us in a really good place to do project development, both because we know where the best places are to do projects and what different characteristics we need, and also because we care the most, right? Because we're going to make money both on the project and on the long term of the technology. So I think each technology has a different mix of how much are you going to license this out, and how much are you going to own projects yourselves. I think it just varies. I mean, the heuristic in my mind is the more that a business looks like LNG. So in the LNG business, the liquefied natural gas business, you have very few sites that are all concentrated, right? You've got giant facilities, maybe a couple. The more it looks like LNG, the more we're probably going to have some ownership in a project because it's, a concentrated one place. The more it looks like, you know, power plants or like solar plants, for example. Like solar plants are all over the world. They kind of have to be spread out all in certain jurisdictions. If we invented a solar technology, which we're not planning on, we would definitely license it. But we're not going to own solar plants in Morocco and Germany and California and Florida. And it doesn't make a ton of sense. So I think the more spread out and distributed the businesses, licensing is far and away the best. As it gets more concentrated, where maybe you only have 3 or 4 sites, you might start playing a bigger role in development, and it might start making more sense to own a bit more of the project. And so then you make some of your money on actually selling the commodity. Maybe I make my money on selling direct air capture credits or selling ammonia or hydrogen directly and owning a share of the asset that sells that, and not just on the IP monetization for having invented it and licensing it and designing it.
Mm-hmm. Okay, interesting. That makes sense. That's a really interesting point. I think obviously a lot of people would like to probably make this stuff because I think I'm assuming the margins are higher, right? If you can do it well, but at the same time, we're trying to make an impact, right? So that's why the licensing model is also really helpful to scale things, right? You prove it, and then maybe you still own it and produce some stuff, but licensing it allows other people to use it. This is something. Maybe you could also comment on this. I talked to a few people actually just today thinking about this. That some of these companies are building these technologies in the US, for example, but as it turns out, given the evolution of regulatory markets around the world, Japan and Korea or all these different areas, depending on their circumstances, are more interested in buying technologies than the people in their backyard potentially. So do you have any comments on this or things that you would just make other entrepreneurs aware of as they're starting these types of companies on when it comes to geographies and keeping an eye out?
I think it's a global business. I mean, our major investors is a Korean company, right? SK, and we had an earlier investor who was a Japanese company, JX Nippon. And so we very much have found that, especially in energy, decarbonization is global. The applications of our technology are global. And so I think that's correct, that often, you need to find the right country that's the best place to deploy your technology.
Yeah.
I think the thing I would add would be that the best place for the first one might not be the best place for the scale up, and that's okay. I think you often find that, our largest market's going to be in Southeast Asia because there's growing electricity demand, or our largest market's going to be in Eastern Europe because of X. I would separate the challenge of where is the place we can build the first full-scale successful plant that's going to be lowest cost and lowest risk, and where do we scale the business? In an ideal world, it's the same, right? Then you're building more usable relationships. But building the first plant's really hard, and I wouldn't, I think it's okay to say, hey, even if our plan is to scale this steel technology in Japan, if you have the best demonstration site in the world at a U.S. steel plant or a German steel plant, I think you can diverge those. I mean, there's big cultural differences you have to learn, timeline differences, right? Like, the investing timelines of a Japanese investor are going to be different than a German investor and different than someone in California. And so there's a kind of a different rhythm there as well. But I wouldn't shy away from it. I think it changes over time who's investing the most as well. But I think thinking global is a good way to build the business, and also for the decarbonization challenge. We've got 50-ish gigatons that we're emitting each year, give or take, that we have to get rid of, and they are spread, right? And so we need businesses who are thinking about India, who are thinking about sub-Saharan Africa, who are thinking about Egypt, and they're all, it's energy is super local. I think we've learned this from the Russia-Ukraine war, and both people's resources are different, and also it's a national security concern where you're just going to have different environments and need different solutions in different countries.
Mm-hmm. One thing I'd be really keen, I know we're running out of time here, but I'm really interested to know, do you have any tactical advice or tips on, if a company is building this stuff and they want to have a global perspective, they want to understand the regulatory markets globally, like how can somebody do that relatively systematically? Because I'm assuming there's got to be a way to do it without hiring somebody who's like a 30-year veteran just studying regulatory kind of trends globally. Like how could somebody do that?
Um, I guess the two things I would say is I think you should do the first principles analysis yourself, which is, let's say you had something for aluminum or steel, right? Um, you should think globally, but there's almost always going to be a concentration where if you look at, okay, where are all the places that make steel, or where are all the places that have scrap steel? And there's good global data sets. Anyone who's comfortable with the internet and analyzing data in a pretty simple way, you'll find the best 10 places to do it, right? So I think you yourself should be able to winnow down from the world, right, to, hey, these are the 10 places that make a lot of sense. And then if you research those 10 places, you might realize on your own that maybe 3 of them are high potential. I think getting deep below that level is then pretty hard. I think we do usually end up, I recommend paying consultants who have deep expertise. I would say you can get a lot just from talking to people. So not even
Mm-hmm.
just consultants, but talk to partners, talk to people in the supply chain, people who would be your suppliers and buyers, and you know, you will learn a ton. And they're going to tell you, oh no, this doesn't make any sense here, like because of X, or like, oh, the government's considering Y. So I do think you are going to, often you end up paying for expertise. And I think if you're paying for expertise, finding individuals is cheaper than paying for a consultancy. If you can find the person who's a 30-year veteran of the Japanese steel industry who just retired, right? It actually might not be that expensive, and you might get really great expertise. If you go pay McKinsey, right, or you go pay some global consultancy, you'll get great service. They're probably always there. They probably have those people, but it's a higher price service. So it's a half answer. It's hard, and I do think you have to narrow because the world's too big to understand all of it. So you're going to have to find some filter for your technology that allows you to focus in a couple key locations.
Mm-hmm. Yeah. Okay, that's interesting. I guess it's maybe not as hard as I assume. Just not being a policy person, it seems like a pretty daunting task. But maybe we'll see. Maybe we'll see ways to help people narrow that down at some point. Because I really do believe if we're going to actually achieve the outcomes we need, every aspect of building these hard. I mean, climate tech companies in general, but especially hardware companies, every aspect of the mold needs to be systematized to make it a lot faster because we can't have founders who have a really great technical background making massive mistakes just because they don't know how other people have navigated this, because by this time, like, most of the major types of technologies have been built to an extent where you can just go learn from them. But what if they're not able to get access to that person, right?
Yeah. Yeah, I think there are
Yeah.
some places where the expertise or information is readily available. I think a lot of policy stuff is public. Just, government documents are typically public. And then some key knowledge isn't. And I think the same is true in industry. Like, oh, if you want to know how to make paper, you're going to have some information that's public and some of it that's actually maybe hard to find just because it's tacit knowledge, right? So I think that's a great thing to frame up, Silas, about making sure that people can get the knowledge. I wouldn't say that's just government or policy. I think that is equally true, if not more true,
Mm-hmm.
around understanding how current technology works, so you can improve on it. And sometimes you can find the information,
Mm-hmm.
and sometimes you can't. And that's also true in trying to understand regulatory environments.
Mm-hmm. Yeah, got it. Okay, very cool. Awesome. Well, I think we're pretty much out of time. There's some other questions I would have liked to ask, but I think I just will end with, like, what's next for Eight Rivers? Where are you guys looking to go? What's the next big challenge that you're kind of looking
Yeah.
towards?
So we are in the sprint of building the first large-scale plant of each of our technologies. The two that are maybe closest on the horizon is there's going to be a clean ammonia plant we're having an announcement on in a couple of days in the Gulf Coast to produce clean ammonia using the 8RH2 technology to export globally to help displace coal. And, it's a very useful commodity. And working on that direct air capture plant down in Alabama, building a pilot plant, and then designing a commercial scale plant to pull CO2 from the air. got a lot of great partnerships, some of which will be getting announced this year as well, that are going to help us deliver on these big projects. But those are the two that I'm thinking about day and night.
Very nice. This is really cool. It's really fun to see these things actually in action. Maybe someday I can get a chance to come visit one of these things.
Yeah, that'd
I
be great.
love physical things. So this is really cool. I appreciate what you guys are doing. Any final thoughts or pieces of advice to other entrepreneurs out there?
It's really hard and it's really fun. I mean, I think working in hard tech, I think it is hard. I think it's probably harder to make a lot of money than working in software as a service. But I think there's way more opportunity, there's way less competition, and it's just a blast getting to kind of work in with atoms and physical commodities and building physical things.
Mm-hmm. Yeah, I mean, I'll disagree slightly. I think maybe harder to do it, yes, but the total money to be made is actually quite large in the
Sure,
space because the largest companies in the world are mostly not software companies, right?
I agree.
But anyways, man, this has been a pleasure. Thanks so much for coming on, and we're definitely looking forward to what you continue to do with Eight Rivers. Keep it up.